Good day, everybody. This is definitely a non-standard logarithm evaluation. We have a base that is irrational. Now, still the same rules apply, so let's write down a couple of the rules that will come in handy today. Let's say we have log base b of b. Okay. Now, this is kind of the basic relationship between a logarithm function and the exponential function. I mean, they're inverses of each other, but this is equal to 1, and that's simply because b to the 1 is equal to b. Okay, b to the 1 is equal to b. So that's trivial but important. It ends up being the final step in a lot of problems. All right, and then also, if you have log base b of x, let's say x to the n, that is just equal to n times log base b of x. Now, understand this is a function. Really, the x belongs in parentheses, but it gets left out just for readability, allegedly. But this really is a function in the same sense, you know, like f of x. Okay, but this follows from a well-known property of exponents that says you can multiply them if it's in a certain form, if in this form in particular. Okay, so those two rules, and there's some others. I won't write them all down, but these two are particularly important. Now, so what I did is first thing I did is something I normally shy away from. I did a readability substitution. And in this particular case, our x is just going to be equal to the square root of 31 over 29, an arbitrary irrational number. Okay. Now, I shy away from these, but it's just kind of clunky to have to keep writing that down. So this kind of encapsulates the structure a little bit better if you just write it like this. Now we'll shift to the well-known rational exponent, which almost everybody agrees that that's more operational than the rational exponents. There's even been a shift to just get rid of the radical notation, excuse me. But anyway, you can see right here, here's the 1 and here's the 3, and you can write it this way. And in a similar fashion, we can write this object as x to the 5/8. Now we appeal to this law that we just talked about. You can drag this exponent around to the front. All right, you can drag this exponent around to the front. Like right here, all I did was use this result right here. And if you carry on, let's see here, what do we have? Now, I just recopied this, didn't I? Yeah. And now here's something that's quite useful. You can write x as x to the 1/3 raised to the third power, right? But that gives us the capacity to drag this exponent around to the front, and so we would get, let me just write it directly underneath. If we drag this exponent around to the front, like we were talking about earlier, you can multiply 5 by 3 to get 15, so you get 15 over 8. You get the form I mentioned, one of the properties, log of x to the 1/3, and I will write it in the functional notation way most people don't. So this is in the form log base b of b, right? But this is just equal to 1, and so we get 15/8, or yeah, 15 over 8. It's the final answer. And that's it, folks. Fun little problem, and I call it non-standard because it's a very rare case when you see an irrational base. Most people like to use nice, clean integers, you know, but this is a base that's just a little bit bigger than 1. And you could write just stuff like this is more interesting in my opinion because a lot of people are afraid of irrational numbers, but smarter people than me have proven that all the properties for rational numbers, you know, logarithmic properties for rational numbers carry over to irrational numbers, which is kind of a deep thing. I think it gets proved in Rudin, baby Rudin. But anyway, let's write, what do we get? 15 over 8. This is equal to 15 over 8.